Hey everyone, and welcome. Today we're diving into Leetcode problem 1578, minimum time to make rope colorful. It's a fun problem that seems a little tricky at first, but once you see the core idea, it clicks into place really nicely. Let's break it down together. So here's the setup. Alice has a rope with a bunch of balloons on it. The main rule she has is that she wants the rope to be colorful. All that means is that she doesn't want any two balloons that are right next to each other to have the same color. To solve this, we're given two things. First, a string of colors. You can think of each character as one balloon on the rope. Second, we get a list of numbers called needed time. This list matches up with the balloons. So the number at index I tells us how many seconds it takes to remove the balloon at index I. Our goal is to figure out the smallest total amount of time we need to spend removing balloons to satisfy Alice's colorful rope rule. The key word here is minimum. We don't just want to make it colorful, we want to do it in the cheapest way possible. Okay, let's walk through the example from the problem description. We have the colors A, B, A, C, and the needed times 1, 2, 3, 4, and 5. We'll just start at the beginning of the rope and check each pair of adjacent balloons. The first balloon is A, and the second is B. They're different, so we're good. The second balloon B and the third A are also different, still good. But now, the balloon at index 2 and the balloon at index 3 are both A. They're the same color and right next to each other. This breaks the rule. We have to remove one of them. So, we have a choice. We can remove the balloon at index 2, which costs 3 seconds. Or, we can remove the one at index 3, which costs 4 seconds. Since our goal is to minimize the total time, the choice is easy. We always remove the cheaper one. So we'll pay the 3 seconds to remove that balloon, and add 3 to our running total. After we imagine that balloon is gone, the rope is effectively like ABAC. Now, are there any more problems? Nope, no two adjacent balloons have the same color anymore. Since that was the only conflict, our job is done. The total minimum time was 3. Just a quick heads up, we'll be walking through the solution using Python, but don't worry if that's not your main language. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. The main strategy here is what's called a greedy approach. It sounds complicated, but it just means we make the best possible choice at every step. As we walk along the rope, anytime we find a conflict, two identical neighbors, we make a decision right there. The best local choice is always to remove the cheaper balloon. By always making that small optimal decision, we end up with the overall minimum cost. Okay, we've talked about the big picture and the logic. Now let's see what this looks like as actual code. I'll put the full solution up on the screen first. And don't worry, after that, we'll walk through the most important sections together. Alright, here is the Python code for this greedy approach. It's actually quite short and clean once you see the logic. Let's break it down piece by piece. First, we initialize our total time to 0. Then, we start a loop that goes through the balloons. Notice that we start the loop from index 1, not 0. That's because our whole strategy is based on comparing a balloon to the one that came right before it. If we started at 0, there would be nothing before it to compare to. Inside the loop, this if statement is where the action happens. We simply check if the color of the current balloon, the one at index I, is the same as the color of the previous one. If they're different, we do nothing, and the loop continues. But if they're the same, we have a conflict to resolve. Okay, so we've found two identical neighbors. We know we have to remove one. Which one? The cheaper one, of course. We use the min function to find the smaller of the two needed times, and we add that cost directly to our running total. This is the greedy choice in action. Now this final line inside the if block is the most clever part of the whole solution. After deciding which balloon to remove, we update the time for the current balloon at index I to be the maximum of the two we just compared. Think about why. Imagine 3 blue balloons in a row. First, we compare 1 and 2. We remove the cheaper one. The survivor is the more expensive one. Now, when we move on to compare balloon 2 and 3, we need to compare balloon 3 against that survivor. This line ensures the cost of the winning balloon is carried forward for the next fight. It's a really elegant way to handle groups of any size. So how efficient is this solution? For time complexity, we make a single pass through the list of balloons. So if there are n balloons, our time complexity is big O of n, which is excellent. For space complexity, we're only using a single variable to keep track of the total time. We do modify the input array, but we're not creating any new data structures. This means our extra space usage is constant, or big O of 1. Alright, that covers the main solution in Python. As promised, for those of you who code in other languages, I'm about to show the full solutions for Java, C++, and JavaScript. I won't be breaking these down, so just pause the video on your language of choice to check it out. Alright, as promised, here is the full solution in Java. You can see the logic is exactly the same as the Python version. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version of the solution. Again, feel free to pause and review the code. It follows the same greedy pattern we discussed. And finally, here is the solution in JavaScript. Hopefully seeing it in a few different languages helps solidify the concepts. So let's wrap it up. The main takeaway for this problem is that it's a classic example of a greedy algorithm. When you see a problem asking for a minimum or maximum result where you can make a series of choices, ask yourself, can I just make the best looking choice at each step? Here, the best choice was always removing the cheaper balloon, and the key trick was remembering to carry the value of the balloon we kept forward for the next comparison. Alright, before we jump into the other languages, I want to quickly show you a personal project I built to solve a problem that always drove me crazy. It's an app called My Daily To-Do. My biggest frustration with every other to-do app was retyping the same things every single day. Go to the gym, review code, work on the daily Leetcode problem. You know the drill. So, I built my app around one simple but powerful idea: separating your routine tasks from your one-off tasks. Routine tasks, marked with the little refresh icon, automatically reset for the next day. One-off tasks, like ship new feature, get the little puff of smoke icon, and they disappear for good once you're done. This small change turns a dumb checklist into a smart scheduler. If that sounds useful, you can try it right now on the web. The link is in the description. And one more thing I want to make super clear. Right now, as a thank you for being an early supporter, the app is 100% free. There are no ads and no subscriptions whatsoever. This means you get access to everything, including really powerful features like presets, which let you save entire task lists and load them with a single tap. Now, down the road, creating new presets will likely become part of a premium plan to help support the channel. But, and this is the important part, any presets you create now while it's all free are yours to keep and use forever. So, it's the perfect time to check it out on the web, play with all the features, and build out your perfect setup at no cost. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the Playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems, so if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. If you want to support the channel, a few people have asked how I plan my solutions. I'm a big fan of sketching out the logic and data structures on a tablet before I code. It really helps. I've put affiliate links in the description to the tablet I use and a few other good options. Using those links doesn't cost you anything extra but really helps me out. Or, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.